Hello everyone, I am Aswani, Assistant Professor, Department of CSE AIML at MLR Institute of Technology. Today I will discuss alpha-beta pruning. In previous session, we have discussed minimax algorithm, where in minimax algorithm, to find out the best optimal value to move in a game playing, we need to explore all the nodes to find out which one is the best one. But in alpha beta pruning, we'll prune some of the branches which won't affect the final outcome. Let's see the procedure step by step. Okay. The overview of the presentation is introduction about alpha beta pruning and example of alpha beta pruning, and we'll see the algorithm, the minimax algorithm with alpha and beta. So the definition is the strategy used to reduce the number of tree branches explored and the number of static evolution applied is known as alpha beta pruning. I already said we will reduce the number of tree branches, that is, and the number of static evolution applied is known as alpha beta pruning. So this process is also called as backward pruning. First we will start with the leaf nodes and next level until we'll reach the root node. Okay, so this backward pruning is used to modify depth first generation procedure. And here the purpose of applying this procedure is to reduce the amount of work done in generating useless nodes. If you explore all the nodes also, it won't affect the final outcome. Whatever branches won't affect the final outcome, we will prune those branches only. So it will whenever it is generating useless nodes, will prune those nodes, and is based on the common sense and basic logic. How it will be, we'll see in the example. Okay, so in alpha beta pruning, there are two nodes are there. One is alpha and another one is beta, and here there are two nodes which represent alpha and beta, that is one representing lower bound, another representing the upper bound. The lower bound value is minus infinity and the upper bound value is plus infinity. So the alpha will chooses the maximum value and it won't decreases. The beta will chooses the minimum value, it won't increases. Okay, let's see. So one representing a lower bound and the value that is a maximizing node may ultimately be assigned, and another representing the upper bound and the value that a minimizing node may be assigned. Okay, each max node has an alpha value, so the alpha will chooses the max value which never decreases, and each min node has a beta value, okay, which never increases. These values are set and updated when the value of a successor node is obtained. Initially, it won't assign any value, either alpha or beta. It will be assigned with the minus infinity and plus infinity. After reaching level by level, we need to change and update the values. The search is a depth first and stops at any min node whose beta value is smaller than or equal to the alpha. The condition here when it will be pruned the branches is beta is less than or equal to alpha, or alpha is greater than or equal to beta. This is the condition where we will follow to prune the branches. So or equal to alpha, value of its parent, as well as at any max node whose alpha value is greater than or equal to the beta value of its parent. It will check the current node with the parent node whether the conditions are satisfied or not. If the conditions are satisfied, then it will stop exploring the nodes and it will prune that nodes. Okay, let's see how it will be. The example. So here we have taken one game tree. So here we are applying the alpha beta pruning. The first player is max followed by min, because alternatively the players will play the game. And initially alpha is a minus infinity, beta is plus infinity, which means a lower bound value, and beta is upper bound value. Okay, so it will start with the depth first, A to B, B to D, D to the leaf nodes. So here at the max level, it will find out the alpha value. At the min level, it will find out the beta value. First, it will check and change after deciding what is the value, then only it will assign to the D to the value. Okay, so at node D, the value of alpha will be calculated as it's a term for max. The value of alpha is compared with the firstly 2 and then 3. So it is will go to the depth first search. So top to bottom and left to right. So it will start with the last node, left node. So 2 and 3, 2 and then 3. And the max of, first it will take max of minus infinity. Initially it is minus infinity, the lower bound value, comma 2. So it will be 2. After that again it will traverse to the next branch. Then it will take max of, now the alpha value is 2, 2 comma 3. So it will pick the 3. The 3 will be the value of alpha at node D, and node value will also 3. First it will decide the alpha value, later it will decide the node value. Okay, next, in the next step, backtracks to the node B. Okay, so after deciding what is the value of the D, then it will backtracks to the B to find out the beta value, because it is the level of min. Okay, so it will backtracks, and whatever nodes are there here. So 3 is already assigned. So D value is 3. E is not assigned. So initially it will take beta equal to 3 at the level of min, because here it is not decided yet. So whatever value is there, it will take that value. After deciding, again if any changes are there, then it will change that value. Okay, in the next step, algorithm traverses to the next successors of node B, which is node E, and the value of alpha equal to minus infinity, alpha equal to minus infinity, and beta equal to 3. Beta is already taken, but it is not fixed, will also be passed. So the next level, at node E, it will first take the 5 as the value to the alpha, alpha equal to 5. But what is the beta value? Beta is 3. Now it will check the condition. Beta is less than or equal to alpha. What is the beta value? 3. What is the alpha value? 5. 3 is less than or equal to 5. Whatever node will come here, means for example not only 5, if it is a 10 or 100 also, it won't affect in this B node. So beta will take only the minimum value. So here the value is a lesser value already is taken to the beta. So it won't go to that next branch, it will be pruned. Okay, understand my point? Here E equal to 5, because beta equal to 3, alpha equal to 5 initially. So then it will check the condition. If it is alpha equal to, for example, 2, alpha equal to 2, then there is a chance to backtrack and change the beta value is 2, because beta will take the minimum value of these 2. So here D equal to 3, for example E equal to 2, then there is a chance to take 3 comma 2, min of 3 comma 2. But here the value is 5. If the next successor will explore also, it won't to take that value, because at a minimum level it will take only min value. So but max will take only maximum value. If the next value, for example 9 is the value, the alpha will change the value 5 with the 9, even though the min value, the beta won't consider this 9, because this will take only minimum value. Okay, let's see the next step. So at the next step, algorithm again backtrack the tree from node B to node A. Now whatever values are there, that will be updated. At node A, the value of alpha will be changed. The maximum available value is 3. Already some value is there. Initially we have taken alpha equal to minus infinity and beta equal to plus infinity. So maximum available value is 3 as max minus infinity comma 3 equal to 3 and beta equal to plus infinity. These two values now passes to right successor of A, which is node C. At node C, alpha equal to 3 beta equal to plus infinity, and the same values will be passed on to the node F. At node F, again the value of alpha will be compared with the left child, which is 0, and max is 3, 0. So it will ultimately take the 3 only, which is the maximum value, and then compared with the right child, which is 1, and max of 3, 1 equal to still 3. So alpha remains the 3 only, but the node value of F will become 1. Out of 0, 1, it is 1. Okay, let's check. After completing this B, it will backtrack to the A, and it will update the values. Here it will take the values from these two nodes B and C. So initially we are having only 3 value. So it will take alpha equal to 3, and beta is still remains infinity. So it will goes to the next branch, that is C. The values are alpha equal to 3, beta equal to infinity. Next again it will traverse to the next branch, next left branch of the C, that is F. These whatever values are there, that will be carried here also. Alpha equal to 3, beta equal to infinity. Now it will take at max level. So first it will take 0. Okay. So the max of 0, 3. So it will take 3 only. So it is not a 0. Next again it will goes to the 1, 3. It is still 3. Alpha is 3. But what is the value of F? So out of this 0, 1, which one is the maximum value? That will be assigned to the F. So F node value is 1. Next it will go back to the backtracking to the C. Now C values still remains the same. Alpha equal to 3 and beta equal to infinity. So here the beta value now it will changes to 1, because at min level we need to change the value. So beta equal to plus infinity 1, which is the minimum value 1. So it will pick the 1. Now it will check the condition. Already parent alpha equal to 3 is there, beta equal to 1. Now it will check the condition, beta less than or equal to alpha. What is the beta value now? 1. 1 less than or equal to alpha is 3. So the condition is satisfied. Then it will prune the entire branch. It won't go to the next successors of this C node. Okay, let's see. Now node F returns the node value 1 to node C. At C, alpha equal to 3 and beta equal to plus infinity. Here the value of beta will be changed. It will compare with 1. So min of infinity 1 equal to 1. Now at C, alpha equal to 3, beta equal to 1. And again it satisfies the condition of alpha greater than or equal to beta, or beta less than or equal to alpha. So the next child of C, which is G, will be pruned. It won't go to the even one of the successor also. Directly it will be pruned, and the algorithm will not compute the entire subtree of G. Okay. This is the optimal path. A to B, B to D, D to 3 is the terminal node or leaf node. Okay. Let's see the minimax algorithm using alpha beta pruning. So here it will take the position. What is the position? Means a left node, right node. Okay, depth. What is the depth? Either it is the root node or next level. So it will initially start with the 0 at the root node. Then level by level it will be increased. Next, player. Which one is the player? Either max player or min player, because it will changes the rules for the max and min. Next, what is the alpha value? Initially, what is the beta value? Minus infinity and plus infinity. If depth, position, depth, then return value equal to evaluate, position, depth, path equal to nil. Then it will goes to the else block, and it will explore the successor list and generate the position. Next, if successor list equal to nil, then again return the value, means whatever value is there, it will be returned. That is the optimal value. Okay. Else again it will goes to the next loop. It will enter into the loop. It will list out the successors and it will apply the minimax alpha beta pruning. Once again it will goes to the next here. So first initially it will play the max player, later negation of the player. When it is a player, then max player will play, negation player means the min player will play the game. Next, it will update the new value, means whatever we have seen in the example, this is the algorithm for that example. Okay, beta equal to new value, best path equal to add successors comma path of successor list, because to find out the optimal path or optimal move, how we can taken that value, we need to trace that path. If beta alpha, then return value equal to beta path equal to best path, and finally we'll return the value. So here position, generating the positions and evaluating the position comma player. First we need to generate all the positions, in what places, in which places they are there. Okay, this function generates a list of successors of the position, where position represent a variable corresponding to that position. Next, evaluate position and player, in which position and who the player is. So this function returns the number of representing the goodness of position for the player from the current position. Next, depth, in what depth they are playing. At a 0 means root, or next d equal to 1, the next level. Like that it will evaluate. It is a boolean function that returns the true if the search has reached the maximum depth from the current position, else it returns false. So these are the key terms used in the algorithm. So in this session we have seen what is alpha beta pruning. Means, remember, in minimax algorithm we'll explore all the nodes, so it will take time and space to store all those nodes and to find out the best value. But whereas in the alpha beta pruning, whatever necessary, we'll explore those nodes. Which nodes are not affected to the final outcome, will prune that branches without exploring the nodes. So here the condition is alpha greater than or equal to beta, or beta less than or equal to alpha. At max level we'll check this one, at min level we'll check this condition. If the parent is already allocated, the means parent node having the value, then we'll follow these conditions. Okay, so we have seen the example, one of the important example, how it will backtrack and how it will decide the each node value and how it will be pruned. Okay, thank you.